Hello. So I think this is my first time presenting to the Touch Designer crowd, but I wanted to say thank you to this community because 5 years ago I met this guy at the Touch Designer Montreal meetup, and we have been doing crazy stuff ever since, which we will soon show you. This project really kind of took shape in the last 6 months. Obviously we're going to walk through a little bit of that, but we are interested in community and community development. And one of those things is making resources accessible to individuals who might not have access to expensive equipment or most cutting edge technology. And so this project definitely came out of that, out of a gap in having limited options for pixel arrays available, and also seeing that this is something that a lot of people wanted. So I'm going to let Pete introduce himself, and then we'll keep going. Are we not on?
It's not the slide we have on our screen right now, but is it frozen? There we go. Hi, I'm Pete Thornbury. My background is lighting design, and for the past 20 years I've been doing mostly GrandMA 2, GrandMA programming, and then for the past 6 years I've been doing Touch Designer LED pixel mapping mostly, and for the past 6 months we've been really diving into this, adding a third dimension to the arrays of LEDs that we use. Now, Jen.
Sure. So my background is in interactive design. I used to be a Flash developer. Right now I am a UX designer. I work primarily with integrating AI and all things energy. I'm also a community organizer in Boston, Massachusetts. I lead Boston Tech Poetics. So if you're in Boston area and want to hang out with a bunch of nerds, we want to hang out with you. I fabricate things as well. I am a welder, love laser cutters and 3D printers. For a while was making circus hoops and aerial apparatuses, but also, do dimensional sculpture kind of on a small scale because I've got limited room to keep it all. But this is a foray into something slightly bigger. So last year, I flew to LA because I fly across the country to LA to go visit Pete. And I brought this thing in my luggage, which was a couple of boxes. So we kind of had talked about, wouldn't it be cool if we had some type of pixel array project that we could use just to tinker and experiment, to have something to build projects. So when we get the opportunity to work on a larger array, we're ready with content prepared. So we call this one Trogdor. And it is very small. So it's, only what can be fit on a Glowforge, a laser cutter. And we started playing with the grid design and used transparent LED strands, so seed LED strands. We put that together, and that's kind of where it started. So then we thought about it, and we're like, well, what if we make this something that we can take places? Because those boxes were not collapsible. So we said, okay, we want to make this better designed for smaller laser cutters, so anybody with a laser cutter at home could build it. And then we made it so that it bolts together, so it could pack flat, and we made it so it's a little easier to string. So that is Trogdor V2. This is a very small module, so this is a 20 centimeter module. And then we figured out ways to connect them together. And then we showed this at Live Code, their Algorave in January at the MIT Theater Art Space. So this is 16 of them. This is where we kind of made our debut. And we learned a lot of things along the way about the difficulties of stringing these things up and doing this in preparation for a show. Presented that at Boston Tech Poetics, and that is where we said, hey, we're going to open source this. Anything that we do as far as plans and designs, as well as some of the content, like the Touch Designer content, we're going to put that up on a GitHub repo. So you can find this. There's a QR code right there if you want to follow the repo. But we have files up there for laser cutting, for the small one. We don't have the big one yet, but we've got Touch Designer templates and we've got instructions. So if this is something you would like to do, you can have access to the designs, totally free. So then we decided we were going to roll this into workshops because Pete runs the Lighthouse in LA, and periodically we do workshops. So we made a bigger module, which is, this is an earlier version of what you see up there. We made this so that it is 4 of those modules together, so that when workshop participants took it home, they would have something a little more substantial than just a little tiny block. And we switched to using black wire, so you'll see that the lights are white, the wire is black. There are some variations in what you can get for LEDs. Made a change in design direction because it just reads easier, much faster to assemble. So then we went to a partner called the RoboHub in Boston, and we held a workshop there in May. There were 10 participants. We have some of them in the audience here if you have questions about it. But we built these things over a period of 2 days, and we taught people how to program them. And we were using like RayTK for the library. We'll get into that in a little bit in Touch Designer. This is our 3rd iteration on the design of these. And it's like point 1 of that. Okay, so after the workshop, we realized that it was a nightmare to put those things together. Workshop participants mixed up the wiring, so we're like, we need to make this simpler for people. So for our next iteration, we simplified the layout a little bit, made some more clear diagrams, and then we held another workshop in Los Angeles in June. And this one, again, had 10 participants. Everybody got their own array to take home and learned how to do programming. And this time, they actually had time to play with the content, which was fantastic. Even in a short period of time, people made some really amazing stuff on these things. I swear this is the final version. I'm trying, but this is like this is like what you see up here. The difference with this one, like there's a distance between the lights, there's like the pixel pitch. So sometimes the pixel spacing, it's like how much money do you want to spend on LEDs? So here, this is 5 centimeters, but, and we just did that for this event, but in general for our workshops, we have a 10 centimeter pixel pitch. This is designed for 10 centimeters. We're going to keep iterating. I don't know, I'll just keep adding final to the file name. It'll be great. But we will put this one up and make it available for everybody. If you want this one, you would have to get a bigger laser cutter for. And now I'm going to switch it over to Pete, who's going to talk about kind of more of the programming side of all of this and the tech. So here we go.
All right, so we definitely have a lot of content in this presentation that we don't necessarily have to dive into, but if anybody has questions about any of these different aspects, you can come up to either of us and talk about it afterwards. Just a show of hands, how many people understand and or have used addressable LEDs before? Okay, I'll skip past that. So the basic setup is, you can kind of see it. We still haven't gotten to the point where we're hiding everything inside these boxes. There's certainly plenty of room for it, but we like the industrial look, as they say in the production industry. So there's a LED controller. We're using right now Wasatch Pixel controllers, which are relatively cheap based off ESP32, WLED. We're not even using any of the WLED functions. We're just passing streaming ACN directly into the controller. And then there's also a power supply kind of awkwardly taped to the C-stand right now. It always kind of goes somewhere awkward. And then obviously the frame and the rigging that Jenn was talking about. And then the LEDs itself. The LEDs are zigzagged up and down to basically save on controller LED outputs. Some of the other volumetric LED systems, the LEDs just hang straight down and end. Like there's some bigger ones where people can walk through them and kind of like play around in the LEDs. All those strands just end at the bottom. Otherwise, people would be tripping over loops of LEDs. But in order to make this as cheap and cheerful as possible, we basically have to zigzag up and down as many times as we can as makes sense for the height, how many LEDs we can do in a row out of a controller output, and how many LEDs it makes sense where we don't have a whole bunch left over. In this configuration, it's two LED outputs of 500 LEDs, and then it's 27 visible LEDs. We have to basically kill 3 LEDs at the top and the bottom to get mounted into the wooden frame to hold it somewhat taut. It's still kind of loose and wobbly. I don't know if that's because it's too hot or not hot enough in here to loosen them up. But basically, you end up having to kill a couple LEDs at the top or bottom, and then in the software, you just make them always be black. And then sometimes you have to do a power injection run from the end of the strand back to the beginning, so we always try and make sure the beginning and the end at the top. So this is just a grid. There's plenty of other volumetric kind of arrangements you could do. There's no reason that it has to be in a grid, especially with the Touch Designer workflow that we're using. There's definitely other ways to do it. There's other manufacturers and arts groups that make and sell and rent these things. And the workflow is basically the same on the Touch Designer side. It's just definitely a lot easier to map the grid. The one in the middle there is a weird random bundle of a slightly different type of LED that took a very long time to map, and then I just made sure to never unbundle it or move the LEDs afterwards. There's certainly smarter OpenCV based ways to map these kind of things, but that's not for me. So content design methods. There's a lot of kind of tricks of the trade for doing volumetric content. There's actually a workshop in Toronto at the Derivative headquarters 2018, 2017, somebody in here might remember, where I think Marcus was demonstrating some different ways to do volumetric content on a little cube array that they had built. And a couple of them are shown in here. The one that I think most people kind of go to first is the idea of just having a whole bunch of cameras, one for each layer, and then you set the near and the far cutoff to a very slim margin. So it's only really seeing a very tiny chunk of whatever geometry is in its view. And that's kind of demonstrated here with the little hello. If you imagine it's a bunch of chunks and pretend it's just an extruded text, that's essentially what you would see inside of each chunk. And then you would just send each of those squares to different layers of LEDs. This is not necessarily the most performant way to do it because it's, that would be 16 camera passes. And then for the bigger, higher density arrays, you could get up into 64, 128 cameras. And it's usually fine with a couple pieces of geometry or one instanced, point cloud or something. But if you get a little too complex with the SOPs, then it'll definitely slow down. And it's also not the most robust way to view. There's some edge cases where if you get geometry that lines up perfectly with the camera, then it's not going to render anything because it's like an infinitely thin slice. So sometimes your geometry will disappear on some of your slices. So it's one way to do it. But the other way, you can see down at the bottom, there's a rotating camera projecting a banana through the grid. So it's really just a 2D texture that's projected through. There's also kind of in the middle, the idea of taking tops, like a square top and a circle top, and then mapping them with this same method, and then multiplying the results in chops afterwards to kind of get approximation of a 3D object. Obviously, you can't really do things inside of things. There is a attribute transfer method that don't entirely understand how it works, but there's a very old forum post by somebody named Adam Katz. Is there an Adam Katz in the house? But it's a little more robust. And then there's some other kind of options, like taking a video and each frame gets set into a different layer, so it looks like kind of a time machine looking animation. And then the way that we have been doing most of our workflow is using, there's a closer view of the two, ray marching. So traditional 3D rendering is rasterization, where you have a bunch of vertices and faces, and you basically calculate from each vertice back to the camera point, figure out where it intersects a plane. Ray tracing kind of goes the other way, where you shoot out rays from the camera and then calculate all your geometry. Ray marching is a whole other beast. How many people are familiar with ray marching and use it? How many people use RayTK, the toolkit? So RayTK ends up being what is by far the most versatile and performant way of doing volumetric content, almost by accident, because ray marching is you have to define all of your geometry. There's no actual geometry in ray marching, but you define all of your stuff with sign distance functions, which is basically just a bunch of complex 3D math equations. And then normal ray marching is from your camera point, you just keep sending out rays and you keep testing at certain distances until you get a value of 0. Anything outside of the surface of the object is a negative number, and anything inside is a positive number. So if you get 0, you landed right on the surface. And the usual ray marching algorithm is, for each ray, keep guessing numbers in smaller and smaller increments until you get close enough to 0 that you're happy. For volumetric content, it's basically just ask at the XYZ coordinate of the LED what the condition is, and it'll tell you if you're inside or outside, and then you can map that to a gradient, for example, and use it kind of like a lookup table and combine a bunch of lookup tables so you have very precise control of everything that's inside or outside of the ray marched content, as it were. So the last thing that I hope is going to be a workflow is pops. I've been messing with the alpha, and there's a lookup pop, or attribute lookup pop, and a proximity pop that both feel like if they had a baby, it would be the perfect operator for doing volumetric content natively with pop geometry. And in the last 30 seconds, I'll kind of show some of the workflow that we
Turn your ray on first.
do with RayTK. So this is a very simple, this is just a cube in the middle of the array. I'm just like changing the size, shifting it up and down, shifting it left and right, shifting it forwards and backwards. It just proves it is actually volumetric. It's not some sort of parlor tricks. And then we've got a couple other patterns that may or may not read. This is technically 3 donuts rotating in space. It certainly works a lot better if you have a black background and if you kind of blur your eyes a little bit to give a little bit of the bokeh effect, or if you use your phone and kind of set it out of focus, it looks really cool. So that is donuts. It's a rectangle again. What's this one? So this one is some kind of like pulsing open and closed red and blue spheres. It's a little more obvious what's going on. And there's a swirl. it probably would read better if we had more of these arrays. This is kind of the minimum viable product as far as size that kind of reads well. But we'll have this around and set up, I guess, if anybody wants to play around with it or ask any questions or mess around with it. I'm sure there's, I don't remember what the schedule is, but I think there's random time where people can come up and check it out if you'd like. Yeah, I think that's kind of the gist of it.